Hi everybody, we're going to quickly go over our pre-lab for density. And before we start, just a quick review over your qualitative analysis lab sheet. Don't be scared to use multiple pages. Please don't smush. If you need to go to the next page, go to the next page. Make sure you label all your sections. Oops. There's my pen. Make sure you label all your sections, purpose, procedure, results, conclusions, etc. Most of you did well on that. And don't forget to write in pen. You have to write all your labs in pen. And then lastly, make sure you number your pages. So it'll start, your count keeps going. So if you use pages 1, 2, 3 last lab, then you start on page 4 for this lab. So whatever your page number is where you continue on. So what is density? You know density as mass over volume. You learned that probably back in middle school or so, which is great when you have a cube. Everything you do, length times width times height, and figure out what your density, your volume is. However, it doesn't always work that way. When we have weird shapes, when we have spheres, we have to use this awful looking formula. For a pyramid, we have to use this awful looking formula to get our balance. So mass is the easy part. We can put it on the balance and report the weight in grams, but the hard part is the volume. And so some shapes are irregular. Like if I wanted to put my necklace and get the volume of my necklace, how would I do that? We're going to use Archimedes' principle of water displacement. So if you get in a bathtub and you sit down, you'll notice the water rises up, and the water will rise up the same volume as the object. So here, if the water is starting at 100 and it ends up at 150, we can get the volume of the rock by subtracting those two. So the volume of my rock is 50 milliliters. So you're going to be dealing with a graduated cylinder, and the way you read a graduated cylinder is the water in the cylinder will create a little curve. This is called the meniscus, and you're going to get down at eye level, okay, with the countertop, so you can see the meniscus straight on, and you read the bottom of the meniscus. That's where you're going to look, not the top sides, but the bottom of it, to get your actual volume. When you're reading a graduated cylinder, for your significant figures, which you've all done in lecture, is the digits you know plus one estimated digit. So here on this graduated cylinder, I know that my volume is 21 for sure. I know that because it's right here. It's above the 21 line. So I know those digits 100% sure that it is 21, but it's point something. I don't know what this last digit is exactly. So this is my estimated digit. And if I look, it's about halfway through. So I'm going to say that it's 21.5. Now, if it was right on the line, okay, right on 25, you would say 25. You know that for sure. Your estimated digit would be 0.0. All right, for today's lab, here's where you're going to do some things. So once we get started, I want you to, of course, write your name on your lab paper. Turn to your lab partner and ask them their name and put their name on the lab partner spot. Make sure your page is numbered. And then you're going to write your purpose statement. Okay? What are we doing and what are we trying to do and how are we going to do it? So I will help you out with this one. Okay? So what are we doing? We're doing stuff with density. What kind of stuff are we doing with density? If you look at your lab paper, we're finding the density of little glass beads. So the purpose of this lab, make sure it's in a complete sentence because some of you didn't do that last class. The purpose of this lab is to find the density of glass beads. Okay, so that's what we're doing. The question is, how are we going to do that? We're using the water displacement, the Archimedes principle. So by water or volume, either word, displacement. Okay. So there's your procedure. Okay. Not your procedure, your purpose. Procedure, just like last time, you're going to put procedure C attached, and after your lab, you'll staple that together. The data collection and results, you're going to draw the data table that you have on your handout, and make sure you use a ruler. We have rulers for you, so make sure you use one to make sure your table is nice and straight lines and everything. And then, of course, your conclusion will go on a separate page, just like we did last time. And it does not have to be in complete sentences, but you do need to number your questions. Okay. All right, so the big thing for today's lab with the data table is you are getting some glass beads that we have up at the front counter. Okay, and you're going to get the mass of that. So if you take one glass bead first, you get the mass of that. Put that in your mass of objects column. And then for your total mass for number 1, for trial 1, they're the same. For trial 2, you're going to take the mass of a second glass bead. So that's glass bead number 2. And if you notice, I'm adding my total from the previous trial and my new mass of my new bead to get my total mass. Okay, so you can ask more questions about that if you have trouble with that. Initial water volume is going to be the same for everything. Your final water volume is what you're reading. Your total volume is your final minus initial, gives you your total volume. Okay, that says initial. Yeah. All right, so we'll quickly go through a second video going over graphing in the algebra so you know how to set up your math for your graphing.